Okay, so, yes,
Recording?
I'm recording, thank you, yes. Notice I updated all of my YouTube stuff last week, so everything's up there, it should be up there. It had been a while.
Have you put in the test or no?
I meant to over the weekend and just didn't get to it, I'll do it today.
No,
Not
you
the-
should not.
Oh, yeah, yeah.
You move on.
Okay, so the next test that we're gonna be doing this week is the related rates test, and so let's get some practice, okay? Because this is coming up. So let's go through our related rates steps here, right? So first step is picture, and they actually give you a picture here. I'm not gonna make mine quite as fancy as theirs, but it just essentially looks like this, doesn't it? We've got a wall of a house, and there's the ground, and we've got a ladder that's propped up against the house, right? And we are moving, it's a 25-foot ladder. The base of the ladder is being pulled away from the wall at a constant rate of 2 feet per second. So they want to know how fast is the top of the ladder moving down the wall when the base of the ladder is 15 feet from the wall. So we need some variables here. Now this is, and I want you to really, pay close attention to how we do this, because there's some stuff here that's important, that makes the problem easier to read and interpret, and we're going to be using it a lot next chapter, the same way of thinking, okay? So, what are some variables maybe I could use here?
Right. No.
What?
Right?
Well, okay, but let's plug some variables maybe into my picture here.
Height,
Okay, so the height and the,
distance.
okay, so how about if we call them X and Y, being as it seems to match, you can do whatever you want, but it seems to match, an XY coordinate grid a little bit, right? Okay, now what about the length of the ladder? Should I put a variable in for that too?
No.
We already know it.
Ah, okay, good. I should not. I don't want to put a symbol in for the length of the ladder because here's my thinking. It's not like it's wrong to do this, but it's almost semi-wrong because it's gonna give you the impression a lot of times when you look at the picture then that it's something that can vary. So I firmly believe that whenever you can, you should write numbers in your pictures because numbers are constants. Variables vary, exactly. So let's just write a 25 on here, right? And we know our units, we can leave our units off. Our units of length seem to be feet and our units of time seem to be seconds, right? Okay, so there's our picture. Now let's do, what's next?
Finding what they gave us.
Okay, yeah, we need our snapshot values. What did they give us? What are we trying to find?
That's what I
So in this picture right here, or in this problem, what are the things at this particular frame in the movie? What are the snapshot values of any of the variables or the rates of change of the variables?
15 feet.
Okay, so that's the base is 15 feet from the wall. So so what is that? What am I labeling there? That's X. Okay, good. So X equals 15. What else do we know?
The length,
Okay, say it again.
the length of the ladder.
Length of the ladder is 25 feet. Good, got that.
The thing,
Okay, yeah, we'll get there.
Find why.
Define height too,
Any other quantities given to us in the,
English.
The right.
okay, what rate?
2 feet.
Okay, yeah, it's 2, something equals 2. Okay, so what's that gonna be, Braden? X dot. Positive or negative? Yeah, positive because it's increasing, right? The base of the ladder is being pulled away from the wall, so X is increasing at a rate of 2 feet per second, right? We'll just leave the units out. What are we trying to find?
height, you're trying to find Y.
Y dot. We want to know how fast is the top of the ladder moving down the wall, okay? So we need Y dot. Very good.
But we don't know why is either.
Well, we're not given Y directly, are we?
No, we couldn't figure it out.
Okay, but maybe we could figure it out. So what is our,
We could do a triangle.
yeah,
So,
what is our parent equation here? If we ignore the dots, Hunter, if we ignore the dots, what is going to be the equation that relates the X's and Y's here?
X squared plus Y squared equals 25 squared.
20, okay, X squared plus Y squared equals 25 squared. Good. Everybody agree?
yeah.
That's our parent equation. Good.
Oh.
Cause we're trying to find y.
So now we've got our parent equation, what do we do?
Plug
Plug in and add to
Okay, no, hang on, plug and chug is, we can't do that yet. There's an order
Because
here.
we'll give it up the variable.
Okay, good, because if we plug in values now, those become constant, right? Those look like constants. We have to differentiate, always differentiate before we plug in values of the variables, before we plug in chug. Same thing we'll be doing in our next big stop in chapter 3.
Antiderivatives?
No, not quite, not quite. Okay, so let's differentiate. What does this give us if we differentiate implicitly? Okay, now hold it. Now, what are we differentiating with respect to?
Y.
Okay, now let's, time, good. Somebody tell me, how do we know we're differentiating with respect to time?
Because it's a relationship.
Because those are the kinds of rates, you're right, those are the rates we're given, aren't they? We're given rates in terms of feet per second, right? Which is why we recognized that we were given x dot and looking for y dot, right? We know that a dot means the derivative of a variable with respect to time, right? So now just think about this in terms, don't get lost sometimes in just the process of doing this whole thing. Think about why we're doing this. We're trying to start with this parent equation, and we want to relate the rates, which means we want to come up with a differential equation. All that means, remember, is an equation that has one or more derivatives in it. Well, we want to have these derivatives, right? We want to have x dots and y dots in our equation, differential equation. So we're differentiating implicitly with respect to t, right? So what is, I ask again, what is the derivative of this first term then?
2x dot.
Okay, good. 2x x dot plus 2y y dot equals 0. We can make things simpler by doing what to both sides?
Subtracting.
True. Divide by 2, how about? Let's get rid of those guys. And then all we have to do, if we want to solve for y dot, we'll just isolate y dot, right?
Yeah.
Okay? So when we isolate y dot, what are we going to get?
Negative x dot.
Okay, good. So now all we have to do is plug and chug, except, what's our problem?
We don't know why.
We don't know why. So here's a fork in the road. We have a couple of, I think, just about equally good choices here. Somebody help me out here and tell me what's one thing I could do here to deal with that problem. Say it again. Go ahead, Brian. In what way?
Find y, using x and 25.
Okay, so,
Using 15 and 25.
okay, good. So what we could do is we could plug in this value of x up here and solve for the corresponding value of y. Does that make sense?
Yeah.
Because what we're really trying to do is we're trying to just add another piece to our snapshot variables. Agreed? We just want to know, this is what Ryan's suggesting, and this is a perfectly good way to do this. We want to be able to just add another piece there so we could plug it in when we plug and chug. So that's fine. We can go back to that snapshot then and say, okay, for that particular snapshot, we know that x is 15, so y would just equal, well, y squared would equal 25 squared minus 15 squared. So that's 625 minus 225 is 400, so what's y?
20.
Yep. Well, plus or minus, but we know it's 20, right?
Not
Doesn't
really
have to
negative.
be positive.
It does, because they're distances, right. So we could just plug in y equals 20, now we're done. Okay, that works. That's a perfectly great way to do this. The other way we could do this, can anybody think of a way that where we wouldn't have to explicitly solve for y?
Could you just say it was 0?
We can't just say it's 0, because y does probably have a non-zero value.
Everybody does.
But what could we do, instead of having to specifically solve for y and add that as a snapshot value, could we maybe rewrite our answer in a way that doesn't use a y?
Yes.
Solve for y. Good. So the other thing we could do is we could take our original parent equation And we could explicitly solve that for y in terms of other stuff and substitute. You take your pick. Honestly, it's 6 of one, half a dozen the other, because you're doing the same work either way. Okay. I would guess people probably like that way, the green way better, but the orange way would just say this. I'm gonna make this the orange way. The orange way would just say, so y equals the square root of 25 squared minus x squared, right? And I'm gonna substitute that in down there and get y dot equals negative x dot divided by the square root of 25 squared minus x squared. It doesn't matter. Either way, when I plug and chug, I'm gonna get the same answer. Do you see the difference there? It's kind of just a difference in maybe the order of the steps you use.
So just in case you can't find y.
Right? Either way, let's go ahead and just plug in here, how about, being as we already did that work to find that y is 20. Either way we slice it though, we're gonna get y equals negative 15 times 2 divided by 20. So I'm gonna get negative 3/2. Okay. Now we gotta be careful when we answer this question. How fast is the top of the ladder moving down the wall when the base of the ladder is 15 feet from the wall?
And 3.5 feet per second.
Yeah, at 1.5 feet per second.
Why?
Why do I not, why what? Why don't I include the negative sign?
Wait, why is it just 5 halves?
3/2.
Oh, it's 3
Because this is equal to, go away.
Because isn't it moving down, making it?
It is, you're right.
So we don't need to put the negative.
Right, okay, but y dot is negative, but the way the question is asked, it's just like saying,
Oh, the rate. There it is.
right, it just wants to know how fast is it moving, the question says, how fast is it moving down the wall? Well, it's moving down the wall at a rate of 1.5 feet per second. Okay.
So it's just like implies that's negative.
Right.
It's moving down.
The fact that it's moving down is saying, we know it's negative, but what's the, how negative is it? You know, what's the speed? Yep.
So how are we supposed to know just from like how the,
Listen, please.
so how are we supposed to know just from how the like question is worded that that's what we're looking for, the y dot?
Because, well, based on the variables that we assigned, here's how we know. Because if it wants to know how fast is the top of the ladder moving down the wall, so that's in our picture that would be that, wouldn't it? Right. So that quantity, the vertical height of the left end of the ladder there, we called y. So if they're asking for how fast is that changing, how fast is it moving, well, they want to know, what's y dot then? Does that make sense?
Yeah.
Okay.
I want to answer the
Okay, so now let's go a little further with this and let's ask a different question. Okay.
Yes. Yes. Go home. Who's they, right?
Okay. We're gonna change this a little bit. Now we're gonna ask.
Is this part 2?
Yep.
So it's 2, not 1.
Uh,
Okay.
I don't wanna say how fast, that's a bad way to do it. Let me say,
You were.
Why did I write anything down? As I should. Oh my god.
It's okay, we did it almost.
This triangle.
Maybe it's trying.
Oh, like that actually.
okay, there we go. That make sense? Same picture? Everybody agree, same picture? Thank you.
Oh, I was gonna say.
What's that?
Like
Almost.
a backpack.
Can't we just do this thing?
Okay, it's almost, it's very, very similar, isn't it? Right? So should we just make, well, no, I already wrote it up here. So what are the snapshot values? X equals,
24.
good, 24. X dot still equals 2. And we're looking for, no?
I'm sorry, why is X not equal to?
Because it's right there, right? That part was the same as last time. What are we looking for here?
Why dot?
No?
Oh.
It says consider the triangle formed by the ladder, ground, and house. So here's our triangle, right? We want to know what's the rate of change of the area of this triangle. Okay. So what are we trying to find?
Area.
Not area, a dot, right?
I don't like it anymore.
Oh, sure you do.
So, when you say the change of this triangle, you meant the area of the triangle?
Right.
Okay, I thought.
What's the rate of change of area? What's of, yeah.
So that's why.
Okay, cause I was just like, okay, triangle.
The area of, yeah, right, so I just didn't write it down correctly. We want to find the rate of change of the area of this triangle, right?
That's why.
Okay, so what's the formula for the area of the triangle?
Half.
X, Y.
That's why, yeah.
1/2.
Why?
Okay, so now you gotta really think about this. I want you to stare at that for a second, and why, do you think this is easier or harder than the last one? It's a little harder, how come?
Because it went
Yeah.
to math, it wasn't hard.
I was really hoping.
You don't know why.
Okay, well, we don't know,
Oh, we can find the, cause there's
okay.
a product, there's.
Okay, good, right here. Hey, listen, please. Listen. Okay, it's a little harder because we've got a product in our function, and so that means when we differentiate, we're gonna have to use the product rule, right?
Yeah.
Unless we can avoid it. Is there a way that we could, this is kind of sophisticated, this is gonna be really big next chapter too.
Okay.
Is there a way that we could relate X and Y? Could we come up with what we're gonna call, next chapter, we're gonna call a secondary equation? Which means an equation that relates those two variables so that we can eliminate one,
Yeah.
right? There is, isn't there? What is it? Pythagorean theorem. Okay, we know,
This, I did earlier.
we know that X squared,
You can replace Y for what you replaced Y for in the orange one, in the orange solution.
right, right. So we get X squared plus Y squared equals 25 squared. And now what we've gotta do is we've just gotta ask ourselves, is this gonna be worth it or not, right?
No.
We did one like this before. Remember, we did the one with the sand pile, the conical sand pile? And we had, I think, I can't remember what our variables were, X and Y or R and H or something like that. I can't remember. R and H. And it was very helpful for us to eliminate a variable. Okay, now this time though, it's maybe potentially not gonna be quite as useful, because look, if we already did this, if we solve for Y, y just gives us back the square root of 25 squared minus x squared. If I make that substitution, I'm still gonna have the product rule, aren't I?
Yeah.
Right.
Yes, you will.
Probably even worse. More things to do.
Wow, it's awful. Just made it worse.
So there's our equation, right?
Yeah.
Okay,
I don't know.
we can certainly differentiate that, and that's fine.
Wait, but don't we know
Like, we go the other way?
Yes, we do, but we don't
Yeah,
plug yet
plug in it.
because it'll take.
You're liking the other way better?
Yeah.
Okay.
Consider that kind of.
Okay.
I don't like.
So what are we trying to figure out? Don't we just do
Because
the
if you have
product
square
rule?
roots, you get plus and minus.
Okay, raise your hand. I'm not people raise your hands now. Say, Hunter's got the floor. Go ahead.
I don't like this way. I like the square roots. I'm gonna.
Okay,
The other way.
there is.
Who's gonna
Hunter is recoiling from the square root, and I understand why. Because that square root, we've got a product.
It is a
Little bit.
beautiful thing that needs to be appreciated.
Maybe another day.
What if we were to instead?
What do you think?
I know what I'm thinking, but I'm gonna let you guys figure it out. Just wait a
Tell
second.
me something smart.
Get rid of the square root.
I'm just gonna wait here for a second. We're ready to roll.
Why?
Yeah.
We did like
Yeah,
that.
if you square it the other, yeah.
Okay.
What's the square root?
That would be a really long.
I still think the other way's better.
Okay. Shall we find out?
Alright.
Just do pick two numbers, and then just do the math, and you see why.
Maybe if it was the square root winds up being a nice number.
Okay, so the square root is gonna be a little bit hard to deal with. It is, because I've gotta treat it as a 1/2 power, and I have to differentiate before I can plug and chug, right?
Yeah.
So, I mean, we can do this, but we have to decide if it's worth it. So this is one
The
possibility.
fact that you're questioning it makes me wanna question it.
The other possibility has two variables in it, but let's just see. Maybe it's not that big a deal to just add a couple lines to our snapshot variables, right?
Yeah.
Do you see this is a real issue though that we're gonna have to deal with in doing this problem. We gotta make a decision about what's the best way to do it.
The blue one.
So let's just, this is gonna be an ugly one to do. This is actually pretty easy to differentiate, right?
It's just
So if we differentiate this, what do we get?
A dot.
Whoops.
Oh.
Equals,
Is it?
equals 1/2, we'll leave that out front, times
X, Y.
okay. Now, that doesn't look so bad, right? The derivative's pretty easy. It's just a matter of, can we find the stuff to plug in? We're not given y or y dot, but it was really easy to find y, wasn't it?
Yeah.
Yeah.
Y was no big deal. In fact, we can do that again. We know that when x is 24, y would just equal the square root of 25 squared, which is 625, minus the square root of 24 squared, which is like,
It equals 49, and then if you square it, it's 7.
right, it's 7, right? It's a 7, 24, 25 right triangle. So we're gonna get y equals 7, that's easy. Is it easy to find y dot? Well, kind of,
Sure.
isn't it? Because look at this equation right here. We've got a pretty easy equation that relates x and y, right? If I differentiate that like we did last time, what did we get? We just got 2x, x dot, plus 2y, y dot equals 0. So in other words, y dot equals negative
48 over 7.
that, right? Okay, but that's all stuff that we now know, isn't it?
Yes.
Yeah. Wait, so why?
Hey, there's just too much talking. Right now, you gotta just focus. If you have a question, just ask me, because everyone needs to hear it. Okay, but look what we got here. We filled in what y is. We know what x is. We know what x dot is. we can find y dot.
Yes, you
Right?
can.
It's no big deal. So we get y dot equals negative 24 times 2 over 7. Whatever that is, right? That's just some number. So that's negative 48 sevenths. We'll put that up there.
That can not be negative.
Right?
So we still have to count.
Why cannot be negative? Why?
It's a
No,
rate of change.
y dot is negative here, isn't it?
Why?
It's a rate of
Why
change, it's
cannot?
not a length.
Y dot is negative because as the bottom end is pulled away from the wall, y is getting smaller.
I thought it was happening on the time before, but then that's gonna be.
Okay, it was, but in the time before, the question was asked in kind of a goofy way. It was asked in a way that said, oh, where is that? Right there. It was asked in a way that said, how fast is the top of the ladder moving down the wall?
It's
Right.
like down, though.
So down means, we already know it's going down, but just how fast, right?
Okay. Okay.
Okay, in this problem though, we're trying to find the rate of change of the area. So now we've got all these snapshot values that we need to answer our question. We can just plug those into a dot, right? We can now plug and chug with those. To me, that's easier than having to differentiate this pretty bad looking product.
So,
Okay?
So just plug those into them.
Yeah, just plug them in and we're done.
Okay.
So what do we get when we do that then?
We did crossing. A dot equals 1/2 parentheses.
Yeah, so x was 24.
Times negative 48 over 7 plus,
What was y? 7
uh.
times 2?
Yeah.
Whatever that is.
Not
That's all
our
right.
answer, please. Negative 1.
So what is it, just as a decimal, approximated as a decimal, the two places, what's it give us?
Yeah, the
Yeah.
fraction.
It's not gonna be this,
Negative 75.29.
Do we say negative?
What should the units be if it's rate of change of area?
Feet per second.
Square feet per second, yeah.
Wait, do we keep that one negative?
Yeah. Why do we keep it negative? Because what's happening to the area here? The area is going down. Yeah. Okay. What do you want me to scroll? Scroll where? Up or down?
down.
Down? Okay. Yes, ma'am.
Okay, so I'm confused between the green and blue. Did we use part of the green in
No.
blue, or- Then why did we use x squared plus y, no, but up there?
Up here. Okay, well, I guess we used this in a way.
So, where did we get that from?
Okay, because that's just Pythagorean theorem, right? We know that x is 24 at this snapshot, so we found out that y would have to be 7
Okay,
at that frame in the film.
okay, but that was really part of what?
Yes. Mm-hmm.
Okay.
So we abandoned the green approach, and what we did instead, we decided that it was easier to just add some extra information to our snapshot variables and differentiate with the x and the y intact, right? Rather than have to solve for y in terms of x and differentiate. If we had done the green technique, we would have ended up with an ugly derivative with only x's and x dots. That would have been the advantage, but it's not much of an advantage. Those are pretty easy to find,
Okay,
right?
so we just found the other one.
Yep.
Okay.
Okay? All right, last,
We have 1 minute, by the way.
oh, 1 minute's all.
Yeah.
It's Monday.
You